Welcome MEEN210 students. In this video I'll be solving this exercise that you see here, following the same steps that we followed to solve the other previous exercises earlier this week. Looking at the given shape, as mentioned, a good practice would be always to try to find the view that has the most number of features that you can represent as your basis for your 3D model. And for this shape here, I can see, if you just for a minute try to ignore the smaller details, I would say that I can see this shape as basically a large block, a large rectangular block down there, and then on top of that corner there's another block above it. Also note that the top block is extending slightly behind the lower block, and then we have those additional features and so on. Let me start by doing this. So I'm going to start by building a small block down there representing this base, and then followed up by this top block over there. I'll start by opening a new file. I will use millimeters as the units, and I'll pick the top plane to start drawing the base. Before drawing the base, let's have a look at the dimensions. So what is the size of this base? So looking here, we have the 20. We have this 20 millimeters, another 20 millimeters, and then we need this distance so we can figure out what's the total width of the part, and the distance can be found here, 28. So the total width of this part would be 20 plus 28 plus 20. This is 68 millimeters. And what about the depth of the part? So for the depth, the information that we have is as follows. So if you look up here, we have 53, starting from this corner here up to the beginning of the top block. Okay, then we have this 16 here from the 53 to the end of the block. So the depth of the block would be 53 plus 16, which is 69. So it's basically 68 by 69 deep. And the height of this block is here 35 millimeters. Okay, so I'll go here to rectangles. There was no specification about the specifics about the location of the origin, so I'll just assume it's this bottom left corner. So this here will represent the depth, which would be, again, if you sometimes some students can be a little bit skeptical about their math skills during modeling. So if you have any doubts, just simply type the numbers in an equation. So it's 53 plus 16. So it will add it up for you. And for the width, you can type 20 plus 28 plus 20, which will give us the 68. Then we'll exit, go to extrude, and the height is 35. And this represents the bottom part of the model. Now let's build the second part, which is this block here. So I'll pick the top face of the part. Actually, I'll pick the same top plane, so because this thing extends beyond the end of the bottom base. So I will assume that it's starting from the same level, same plane. So I'll pick the top plane and I'll start a new sketch. And I will draw a random rectangle that extends a little bit outside from the back side, but it's aligned to the side from here with the base part. And the size of this rectangle would be, we have here, if you see, we have 18 plus 9 represents the depth of this part. So 18 plus 9, let's add this. 18 plus 9, 27. And then we need to figure out the width of the part. So to find the width of the part, let's have a look again at the drawing. Let's see what information do we have here. Okay, so we are given the width of this part here. This part here, it has a width or a radius of this fillet of 10 millimeters. Then we have a 6.5. So if you follow the extension lines of this 6.5 millimeter dimension, you will see that there's a center line here. This center line extends to the center of this semicircle over here. And this line is actually in the middle or in the mid distance between these two parts over here. So this basically, the 6.5 millimeters represent the radius of this section here. So to add up or to find the exact width of this section, we'll need a 10 plus 2 times 6.5 or 13 and another 10 over there. So 10, 13 and 10, which is 33. Again, if you are in doubt, simply type them one by one. 10, 13 and 10. And the reason why it's still underdefined, because if you exit and try to move the underdefined section, you'll see that the rectangle still has the ability to move up and down, and we need to stop this from happening. And this would only happen by defining the last dimension from the corner or the origin point, which would be the 53 millimeters that mark the starting point of that cube. Now it's fully defined, we can exit. We'll go back to extrude. But before I extrude, again, we need to know what's the distance of the extrusion. So we have the same height of the bottom base, which is 35. Then we'll add to it 16, which represent the height of this section above the base, plus 18, which represents the height of this part over here. Or what you can do is that we can just extrude up to this surface here, and then we can add those parts later. So let's do that. So I will extrude only as 35 plus 16. So I'll go to extrude. 35 plus 16, and this will be the shape here. I think you can start to see some similarities starting to appear. And then, just to have all the features ready, I will pick this face and I will draw on it. What I'm going to draw right now is the following: is straight line, tangent arc, line, another tangent arc, vertical line, another arc, and a line. So what I drew here is a shape that represents the profile of these features. So these features basically are two extrusions, which are here on the sides, and one extruded cut that we need to create. So So we can do this in this way. So let me close this first, and I need to close this line here and close this line over there. Sorry. So I ended up with 3 profiles, one here in the center, and one there. Let's add all the relations and dimensions, then I will explain what I'm doing exactly. So I'm making these 2 lines equal and the arcs equal as well. I know that from the dimensions the radius here is 10 millimeters. We need a tangent relation here. Then we need a radius of 6.5. And then we are given here, if you notice, a 2 millimeter distance. The distance is the height or the location of the center of this semicircle from that edge. So the center of the semicircle is 2 millimeters below that edge. So let's add this here. From the center to this edge, we have 2 millimeters. And let's see why this is still underdefined. Yeah, we did not define the height. So I'll go here and I'll pick this line to this line, and the height is 80. Now it's fully defined. Okay. Now we have a sketch that represents the 2 features that we want to create, but we cannot, as you know, we cannot create an extruded cut and an extruded boss at the same time. So I will use this sketch to do the following. I'll create the extruded cut first. So with the extruded cut command selected, it's waiting for me to select the areas that I want to use from the sketch. And the reason why it's waiting for this, because it detected multiple sketch profiles. So I'll pick this section here and this section here, and we'll select through all, and I will cut. So that's the cut first. Then I will open the extruded cut and reuse the same sketch once more. For this I will select extrude base. Now again it's waiting for me to select which parts of the sketch I want to use, so I'll pick this one and the other side. The thickness is 9 millimeters. If you're wondering why, so look here. So the thickness of this part is 9 millimeters. So I'll type 9. And you'll notice that the sketch is starting from the beginning of the cube, while we need it to be starting from the back of the cube. And if you remember, we discussed this feature or this situation in another example before. And what we need to do is that from the From menu, we need to select the surface where we want our extrusion to start from. So I'll go and open the menu here. I will select surface, face or plane, and I will pick the back surface like this. You'll notice that the preview looks correct. 9 millimeters, accept, and this is the result. Okay, it's starting to take shape, so let's continue working. Let me add a few minor features so you can see the similarities between my part and the original drawing. So I will add this fillet over here at this edge. The radius of this fillet is 14 millimeters here. So let me go pick the fillet, type 14 in radius, and I'll pick this edge. Make sure that full preview is on so you can see how it looks, and I will accept. Okay, now you can see the similarities getting more and more obvious between our part and the given drawing. Let me also add this fillet at this back corner here, this one, and the radius here is 10 millimeters. So I'll go back, go fillets, type 10, and I'll pick this edge. Good. Moving on. The next thing next feature I will make would be this opening here, in this area here, this section over here. So for this, on the top surface of the bottom base, or the base part, we need to sketch a rectangle that is 28 millimeters wide by 28 millimeters depth, starting from the front edge of the part. So I'll pick that surface and I will draw a rectangle starting from this edge up to here. So it's 28 by 28, which means it's a square, so I'll pick inside and make equal, and this would allow us to add only one dimension. Now we need to know where it should be along this direction, and this information is already given to us. So if you notice here, if you notice this edge here, which marks the beginning of our rectangle, this edge is 20 millimeters from the far edge of the base. So this means that this line should be 20 millimeters from this edge over here, and this should be the correct location of the rectangle or the square. So we can exit the sketch, go to extruded cut, and through all. Okay, so I think we're getting closer. The shape that you see down here, this arc shape and the step, this will show up later as soon as we make the extruded cut using this profile on this side. So let's actually do this right now. So I'll go pick that face and I will draw something that is similar. So what is this shape? So this shape is basically a vertical line, horizontal line. Then notice, this is very important, there's another vertical line that's 7 millimeters high. Then we have a semicircle, then again another 7 millimeter vertical line, horizontal and vertical. So let me draw something draft that looks like this: horizontal, vertical, horizontal, a semicircle using a tangent arc command, vertical, horizontal, vertical, and close. So this is the profile that we are going to use. Now we need to refine it to put it in the correct location and adjust its dimensions. So I will use the Smart Dimension tool and I will start by dimensioning the bottom line, which is here seen as 41 millimeters. So I'll pick it here, I will type 41, and then I will make sure that these two lines are equal and these two lines are also equal. Then I will use the dimension tool again to make this line 7 millimeters, and the radius is given as 16 millimeters. Okay. So that is okay. These are all the dimensions that define our profile, but you still see that it's underdefined and it can slide left and right, and it's okay. It's also, its size can change up and down because we did not define the length of this line. So the length of this line is given here at a different location, and this is why you need to read your drawings very carefully. Look here, you see this 7 millimeters. Look where the extension lines are going. So this is from the bottom up to the end of that vertical line. So we'll go here and add another 7 millimeters. So this will define the height, and finally we need to know this distance to stop it from moving, and this distance can be shown here. If you extend the beginning extension line of the 41 millimeter dimension back there, you'll see that it is 14 millimeters behind the bottom edge of the base. So this here represents this side, and this is 14. Now the sketch is fully defined. We can exit, go back to isometric view, and extrude cut through all. Now you can see that the shape is coming pretty close to what we need. I can see some differences here. If you notice that this lower line here in my part ends here, while in the drawing it doesn't show up on the other side. So this might mean that this cut was not supposed to be a through all cut. Okay, so for simplicity, let's just assume it's a through all, and let's continue adding the rest of the features. So we have only, I think, one more feature remaining, which is this section over here. This will require us to create an extruded cut, to create this cutout, and then add a fillet over here. So let's start by adding the fillet. So we have a 14 millimeter radius fillet. So I'll go here to fillet again, type 14, I'll pick this edge and I'll select OK. Then we need to make this feature, the last feature here. So here we have a material that has been removed from this corner, right, by a depth of 14 millimeters. So something that cut through this side a distance of 14 millimeters. And if you look from, imagine that we are viewing from this direction, so it has this profile, a straight line, and then a vertical line, an arc, and another straight line. So which is basically a triangle before we added the fillet. So let's sketch this shape over here. So I'll go here on this, select this face, I'll start a new sketch, and you will see that we are given some information. You need to note that this vertical reference or center line represents the center of the semicircle that we used in the previous profile here. And if you notice again here that the start point of our line of sketch is on that center line. Okay, so this is something to note. So, and where does it end? We are not given an angle, but we are given another height from below. So if you look down here along that line, so this line sits 14 millimeters above the bottom of the part. So let's translate this into a sketch. So I need a sketch line, so that's touching this edge, and it's touching, again, be careful, I do not need to snap to the midpoint of this line, so just go touch it at some other location, and this will be the draft line. Now let's add dimensions to make sure that it's correct. So this distance should be 14, and we need to ensure that this point is aligned vertically with the center point of the circle. So I'll go draw a center line, and I'll start by touching the circumference of the semicircle, and then start the center line at its center point, go up and touch that line. Then you can simply zoom in and drag this point to be coincident with the end point of that line, and this would be the correct sketch line. Next, I need to draw this horizontal line, the fillet arc, and another vertical line. And for this, you can see that we already have them. We can make use of the geometry that we have. You don't have to, you don't need actually to draw them again, but we can make use of these edges using the Convert Entities tool. So once more, let me remind you, the Convert Entities tool, what it does is that it creates a projection of whatever lines or edges that you select, and it projects them as new sketch lines on your sketch plane. So in this case, I need to create a copy of this line, and I'm pressing Ctrl down to select the arc of the fillet and the vertical line as well. So you see these three blue highlighted lines. These are selected using the Control button, and then I will just go and tap the Convert Entities button. Now you can see that we have a black sketch copy of those edges. I will use the Trim Entities tool just to remove the excess part of the sketch here and here, and you'll see that the shaded area of that sketch is the shape that we are going to use to create the extruded cut. I will exit this, go to extruded cut, and the depth is, it's a blind end condition, the depth is 14 millimeters. Okay, now let's have a look. Oh, finally, there's one last fillet that I almost forgot down here. So a 10 millimeter radius fillet. So let's add it quickly. Fillet 10, this edge, and that's it. I need you to note that this is something that I did not discuss before. Look here along these surfaces. You'll see that we have these lines over here, and then again here we have these two lines, a line here, a line here, 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 and here. And these lines you do not see here on the actual drawing. These lines actually they are not part of your geometry as a solid model, but they are the separating line between the flat face and the next connected round face, because this is the face that was created using a fillet. It's a cylindrical face that is connected or attached to the flat face here at the back. And similarly, again, this is a cylindrical face that's connected to this top flat face, and that one as well. So this line is just represents the end edge of the flat face and the starting edge of the rounded face. So there's an option, if you want to hide them, you can go to the shaded preview, where you can actually see the geometry as given on the drawing. Did I miss anything? I think this covers everything. The main difference between the model that we have here and the given drawing is this section down here. Let's just assume for now that the bottom cut is a through all cut. Remember to save the part. So let's give it a name. 424 MEEN210. I'll save it under examples. And I will give it a material of 1060 aluminum alloy. And for this I will go and check the mass. And the mass here is 272.47 grams. So please give it a try. This will be the first in a series of practice exercises that I will be posting. I will post a lot of exercises during the coming few days, and hopefully every day I will try to post a video or two for their solutions. Best of luck, and I hope this was useful.